Here we are going to discuss about the causal. First, we have to do the parameter as a redundancy. So let me rewrite the ALMA tutor model. So it will be xt minus 0.4 xt minus 1 minus 0.45 xt minus 2. This will be equal to wt plus wt minus 1 plus 0.25 wt minus 2. And again, it will be 1 minus 0.4b minus 0.45b squared times xt. This will be same as 1 plus 1b and 0.25 b squared is a wt. So finally, it will be same as 1, let me see, it's a b here and b there, xt, 0.5, 0.9, it must be negative 0.9 and positive 0.5, and the left hand side, it will be 1 plus 0.5b perfect square is a wt. Then now we can cancel out this one factor each. So finally, we can make the reduced model is 1 minus 0.9b xt is equal to 1 plus 0.5b is a wt. So now we have a AR11 model. I'm sorry, the ALMA is 1,1 model. So based on the ALMA 1,1, we are going to check the causal. So let me go up here. Okay. So let me remind you what was the definition of the 3.7. The definition, the 3.7 is when we write the model xt is a summation, the infinite summation of the white noise from 0, and the other way we can rewrite using the big phi operator wt, where the big phi b operator is the infinite summation of phi j b power j from 0 to infinite, and the big phi 0 is always 1. If now the infinite summation of the absolute value of the phi j is not equal to infinite or is less than infinite Fahrenheit, then the ALMA model, ALMA PQ, is causal. In general, if it is true, I mean this one is true, then simply say we can, the ALMA model is the causal. You know, before we had these conditions for only ALMA 1, sorry, the AR1, right? But now, in general, yeah, we can check this one. Even based on the ALMA P and Q, then now we can say it is a causal. So let me copy the model is we got before here. 1 minus is 0.9b is xt is equal to 1 plus 0.5b is wt here. And let me copy this one again, right? It's xt is equal to the big phi b is a wt. It's actually, it is the infinite summation of the white noise. So I said it is the MA representation. It's the MA form. Okay, then now I can say it is the phi b xt, and this one is the theta b is a wt, and now we plug the xt is equal to big phi operator times a wt, and we can plug into here. So now it will be phi b, big phi b, wt will be same as theta b, wt. Then now we can cancel out the wt and rewrite. The phi b was, again here, up here, 1 minus 0.9b, and the big phi was the big phi 0 b0, big phi 1 b1, big phi 2 b2. Let me take one more. It's big phi 3 b cube infinite equal to theta b was this. It's 1 plus 0.5b. It's good, right? So now we can take the multiplication. Before, you know, the big phi 0 was 1 and the power 0 is 1. So simply I can rewrite the first term is just 1. That's good, right? So let me take 1 and 1. This will be 1. Next, this will be 1. And the next one, from here, we have a b term. So it's a plus phi 1. And between these two, we are going to have another b term times 1. But there is a minus 0.9, minus 0.9, and b. Okay? So let me erase. Next one, here is a 1 times b square term. And this one times this one. It's another b square. So there was a negative, remember, the negative one, negative 0.9 phi 1 b square. Can you expect the next one? 1 times b cube big phi 3. And here is a negative 0.9b. And here is a big phi 2 b square. We can make another b cube. So it's a minus 0.9. It's a phi 2. It's a b cube. It's a keep going. How much should be? 1 plus 0.5b. It must be 1 plus 0.5b. So far so good? So now, let me see. Okay, let me take 1. Okay, 1 here. And just a second. It's not this way. Here is a 1, and there is a 1. Let's cancel out. And here's phi 1 minus 0.9 times b, and there is a 0.5 b. So the big phi 1 minus 0.9 must be a 0.5. And we don't have b squared here. So the difference is a big phi 2 minus 0.9. Big phi 1 must be 0. And this one is also must be 0. Minus 0.9 is phi 2 must be 0. And so on. So from here, I can say the big phi 1 is 1.4. And now here, big phi 2 must be 0.9 times the big phi 1. But how much was the big phi 1? It was 1.4. So it's 0.9 times 1.4. Next, big phi 3 will be 0.9 big phi 2. And how much was the big phi 2? Here it is, 0.9 times 0.4. But here is a 1 more, 0.9. So here is a 0.9 squared times 1.4. What do you expect the next one? The next one is a big phi 4. Must be 0.9 big phi 3. Then it must be 0.9 cube times 1.4. So please look at the first one, second one, and the next one, and the next one. What do we need? Actually now we need the infinite summation. We need the infinite summation of absolute value of the phi's from 0. Remember, from 0. As it must be the absolute value of the phi 0, absolute value of phi 1, and the absolute value of the phi 2. So it will be 1 plus 1.5 plus 0.9 times 1.4, and it's going. And this one, right? Yeah. So now I can say 1 plus. And now here, we can apply the formula. On the top, we need the first term, 1.4, 1 minus, multiplier is 0.9, 0.9 squared, so multiply is a 0.9. So when you do this one, you can do by yourself, but at least I can say less than infinity. What does it mean? The very first one, yes, this one. It was ALMA 1.1 model. What? Causal. Okay, so finally, because the infinite summation of the infinite summation is a Fahrenheit, so the ALMA 1.1 is causal.